So in last lecture, we saw problems based on two very interesting types, and those were linear upon quadratic, and linear upon root quadratic. This is indefinite integration lecture number 16. So we had learned these two very interesting types in last lecture, and we also had some practice problems. So let's have few more practice problems on these types. So here I take 8. It is 8 in the book which I'm referring to. You don't have to worry about the numbers. You just have to see the problems which I'm solving, because whichever book you are referring to, the problems will be of similar type and similar kind. So if you understand how to solve a problem, then you can solve many problems from your respective textbooks. So here I have to integrate 3 cos x upon square root of 4 minus sine square x plus 4 sine x minus 1. Okay, so see, what is the first thing that I do here? As you know, students, integration is all about applying the results. Integration is all about applying the known results, that is the results which you have known. Okay, so when you ask yourself, is there any result working on this? Do you have any result working on this integrand? The answer you get is a very simple answer you get for this. The answer is no. No, there is no such result which we have learned. We have not learned any result which will integrate this directly. There is no such result which will integrate this directly. So what I will do, students, I will go for transformation. Now the transformation thing happens in many ways. So let us start with transformation. You know, the first thing that I write is, I write here, put sin x equals to t. What I do, I put sin x as t. Put sin x equals to t. So then I will differentiate with respect to x. I put sin x as t and then differentiate with respect to x. When I do that, see, what do I get? I get d by dx of sin x, which is cos x, and here I get d by dx of t. I get d by dx of t. What happens next? See, students. So I will get here, next step, I will get cos x multiplied to dx, cos x dx equals to dt. And this is something which I had seen. See, when I saw this question, okay, what was it which I was thinking? I was thinking that in the denominator I have a quadratic. In the denominator I have a quadratic, but it is not quadratic in x, it is quadratic in sin x. It is quadratic in sin x. And remember, students, you don't have a type where you don't have a type where you have quadratic in sin x in denominator. What we know that we have a type where we have quadratic in x. We should have quadratic in x. So you know, since I wanted quadratic in x and I had quadratic in sin x, I tried to get quadratic in t. That is why I am putting sin x as t. I understood that if I am putting sin x as t, it will get me 4t square plus 4t minus 1. Moreover, Moreover, the moment I thought of putting sin x as t, immediately I differentiated and I checked. I differentiated. The moment I substitute something, I differentiate it. I differentiate it to check whether I am getting something to resubstitute. And see, here I got cos x dx. So this all happened while solving. And when you practice, you will also get used to all such steps. So cos x dx is dt. Now see, so therefore I equals to, you will get the new integral, and the new integral will be completely in terms of t. So 3 cos x dx, you will write 3 dt, you will write 3 dt, okay, divided by 4 t square plus 4t minus 1. This 3 I write out, so 3 is out, it is 1 dt, and here you have 4t square plus 4t minus 1. And you know, students, after this what type it is. What type it is? It is 1 upon quadratic. 1 upon quadratic. The only difference is you have here quadratic in t. All the steps you know, 1 upon quadratic, you will make the coefficient of t square 1 by taking 4 common. Then you will find out the last term. You will find out the last term by the formula half the middle term, half the coefficient of t square. Once you get the last term, you will add it, you will subtract it, then you will try to get two squares in the denominator. One is variable square, the other is constant square. Then you will use the results from the set 1 theory. What are set 1 theories? There are 3 theories. 1 upon x square plus a square dx, that is 1 upon variable square plus constant square dx, or 1 upon variable square minus constant square dx, or 1 upon constant square minus variable square dx. Out of those 3 results, any one result you will have to use to integrate this. Okay, I hope you all can solve after this. Okay, we have done many problems, so I am not going to complete this. You will do this on your own. The answer for this question will be, you should get the final answer as I equals to 3 over 4 times root 2 log 2 root 2 sin x plus root 2 minus 2 upon 2 root 2 sin x plus root 2 plus 2. This is the answer that you should get when you will work on this. Mind it, students, it's going to be very simple. Don't worry. Don't worry. Now we have to move to the next question. I find one really good question. Let us solve that. Okay. And that question here is number 9. I find a good question. I don't know why, but then I feel this question is quite important. Let's do this. So here I have here I equals to, question number 9. It is, let I equals to square root of e raised to 3x minus e raised to 2x upon e raised to x plus 1 upon e raised to x plus 1 dx. You know what I will do? I will first of all try to make this numerator square root free, and for that you know what should be the step. Okay, I will go priority wise. First I will make the, see students, I'm not going to be able to solve this unless I know what type it falls for, what type it is falling into. Once I know the type, then I will start getting ideas. So right now I'm just trying to get it into a type. And for that, what I'm doing is I'm making the numerator free from the square root. For that, I will write here e raised to 3x minus e raised to 2x upon e raised to x plus 1. And once again, I multiply e raised to 3x minus e raised to 2x in numerator and e raised to 3x minus e raised to 2x in denominator. And when I do this, what do I get? See, when I do this, I get here, I will write it here only, or else I'll have to turn the page several times. So what I have, see these two, so I get I equals to, first of all, inside the square root, I get here e raised to 3x. The numerator I get complete square, e raised to 3x minus e raised to 2x the whole square. And in the denominator, what do I get? In the denominator, I get e raised to x plus 1 into e raised to 3x minus e raised to 2x, and here you have dx, right? So as we were working for, the numerator becomes the square root free because you have got square here. See, you got square here. Square root of a square. Square root of a square is a. So here what will happen, students? You have e raised to 3x minus e raised to 2x outside the square root. And here what you will do, see, in the denominator you will definitely get the square root. And what do you get? You get the square root, and students, these two brackets will multiply. These two brackets will multiply these two brackets. So let's multiply. This multiplies the first term, then this multiplies the second term. Okay, so see what I get when they multiply. I get e raised to 2x plus 1 into this, so I get e raised to 4x, e raised to x plus 1 into e raised to 3x. So e raised to 3x multiply e raised to x, I get e raised to 4x plus e raised to 3x. Then I have negative sign, and e raised to x plus 1 multiply e raised to 2x. So e raised to 2x multiply e raised to x, you get negative e raised to 3x, negative e raised to 2x you get. Okay. Now this two cancel. So what do I get next step? I get next step as I equals to e raised to 3x minus e raised to 2x dx. Okay, and inside the square root, you know what you get? You get e raised to 4x minus e raised to 2x. See here, e raised to 4x minus e raised to 2x you get. Next step, I will take e raised to 2x common. So e raised to 2x is common. In the numerator, I get e raised to x minus 1. I get e raised to x minus 1 dx. And here what you get, I take e raised to 2x common here inside the square root. So when e raised to 2x is common, you get e raised to 2x minus 1. Then I equals to, I will write this as e raised to 2x, here e raised to 2x into e raised to x minus 1. And this e raised to 2x, this e raised to 2x can be treated as e raised to x square. E raised to 2x can be written as e raised to x square. Anyways that these power and power, they multiply. So when x into multiply, you get e raised to 2x. So e raised to 2x you can write like this. Okay. So when I have here e raised to 2x as e raised to x the whole square, I can take it outside the square root, and here I will get e raised to x, and inside the square root I get e raised to 2x minus 1 dx. How I got e raised to x here? Because I took this outside the square root. And this is actually e raised to x the square. So outside the bracket, it will be without square. Now what happens, students? See, in numerator you have e raised to 2x and here you have e raised to x. So this will cancel 1 e raised to x and you will get what you get. I equals to, you get I equals to e raised to x minus 1 divided by square root. You should understand how you got e raised to x, because here I had e raised to 2x and this is e raised to x, so 1 e raised to x got cancelled. So e raised to x into e raised to x minus 1, and here I have inside the square root e raised to x minus 1. I write this as e raised to x the whole square minus 1 dx. And then what I will do, students, amazingly interesting question this is. Now I go for the substitution. You know why substitution? Because now I understand that it is root of quadratic I am going to get. See, e raised to x square. Okay, and see how the things will turn in our favor. I will write here, put e raised to x. I'm taking this e raised to x as t. There are several e raised to x there, but I am thinking of this e raised to x. I'm going to put this e raised to x as t. So I write here, put e raised to x equals to t. Then I differentiate with respect to x. And when I do that, see what I get. I get e raised to x dx equals to dt. So now here I get t square minus 1. Here I'll get t square minus 1, and see this. This e raised to x dx. This e raised to x dx will be dt. So the new integral that you write in t is I equals to, this whole thing is dt, and e raised to x is t, so this bracket is t minus 1 square root of t square minus 1 dt. And now what type it is, my dear students? It is linear upon root quadratic. Linear upon root quadratic. It is linear in t and quadratic in t. This problem is moreover much simpler because the quadratic in the denominator, it doesn't have the t term. See, this quadratic doesn't have the t term. So one way it is going to be very simple. But the method will remain same. If you remember the method, what was the method? We will adjust the derivative of quadratic in place of linear. So see, the derivative of quadratic is 2t minus 0. So here you should have 2t. So you multiply 2, divide by 2, then separate for that. All this you can solve. I have made this problem quite simpler, taking it to such a step. I believe you will take it ahead and you will get the answer for this. So you can pause your video and solve it now. The answer I will give you after you will have solved. The answer, when you will complete it, the answer that you will get for this problem is, I write the answer, you can tally it. The answer you will get is e equals to I equals to square root of e raised to 2x minus 1 minus log of mod of e raised to x plus square root of e raised to 2x minus 1 plus c. This is the final answer that you should get. Today we are going to take few special important questions from the integral, and two such questions I have written, and these two questions are important for the reason that these two problems can be, these two questions of integration can be solved in by two different methods. So which method should we follow? That depends on you, but I will prefer the method which I'll let you know. So let's first begin. Suppose I'm working on this particular problem. So I will consider this as, see, I can take it as 1 upon 1 cos x Okay, 1 cos x minus 1 sin x, 1 sin x dx. So I can consider this problem to be of the type 1 upon a cos x. If you remember, 1 upon a cos x plus b sin x plus c, and what is c here? C is 0, plus c dx. And you know the complete method, students. The method is you will put tan x by 2 as t. I think that was done in lecture number 14 or 13. You can just check. If you haven't seen that video, you can check that. Put tan x by 2 equals to t. And then for this, when you write x by 2 as tan inverse t, x as 2 tan inverse t, so you will get dx is equal to 2 dt upon 1 plus t square. And for cos x and sin x, you substitute in terms of t. For cos x, you write with the formula, with the help of formula, 1 minus tan square x by 2 upon 1 plus tan square x by 2. So it will become 1 minus t square upon 1 plus t square. And for sin x, when you use the half angle formula in terms of tan, that is 2 tan x by 2 upon 1 plus tan square x by 2, you get 2t upon 1 plus t square. And then you solve this, you get the, when you substitute for 1 dx as this, and you substitute for cos x as this, and for sin x you substitute this, you simplify, you get 1 upon quadratic type. You get the type 1 upon quadratic, and then you know how to solve it, 1 upon quadratic, and you will apply the first set of 3 theories to get the answer. So this is one method you can apply for this. You know, the same method you can even apply for this. You can apply the same method for this. What is it? It is 1 cos x minus root 3 sin x. So 1 is a cos x plus b sin x, and c is 0. C is 0. Okay. So this is one method. But students, here I want to say something, and that is, you know, because in these two problems, the denominator, I have sin x and cos x terms. In the denominator, I have sin x and cos x terms, but I do not have a constant. Because of the absence of constant, these two problems become very, very interesting problem. They become very interesting problem. See, what I'm trying to say is, I have a cos x term. Understand, what I'm trying to say is, I have a cos x term, I have a sin x term, but I do not have a constant here. See, plus 0 we have. We do not have a non-zero constant. There is no constant, non-zero constant here. There is no non-zero constant here, and because of which this type becomes a very interesting type. And we can apply another method here. There is one method which is different from the method that we just saw. We can apply that method here. So I will apply that method, and then you can solve it with the help of that method also. But remember, this method is to be applied when the constant here is 0. The constant is 0. That is, I don't see any non-zero constant. Okay, the constant here is 0 in the denominator. We don't see a non-zero constant. We don't see a non-zero constant. Okay, let's begin. So here I start with, okay, so I will solve this one. I solve this one, and this can be given for you as a practice. So I begin with, I write here solution for, okay, let me write this as first, this means this is the second, so I can write the solution of second. Okay, so as usual, I will write let I equals to 1 upon cos x minus root 3 sin x dx. Okay, so what I will do is I will divide numerator and denominator by, I will divide the numerator and denominator by square root of 1 plus root 3 square. Okay, let me write this thing here. Whatever I said, let me write it here. Okay, let me write it here. So see what did I say? I said divide numerator and denominator by square root of 1 square plus minus root 3 square. 1 square plus minus root 3 square. That is, you have to divide the numerator and denominator by square root of sum of squares of coefficient of cos x and sin x, coefficient of cos x and sin x. Okay, so you can say divide. What is the step here? Divide numerator and denominator by square root of coefficient of cos x square, coefficient of cos x square plus coefficient of sin x square. This is what I have to do. Okay, so here I write what? Dividing numerator. This is for the reference which I have put here. This is for the reference. Okay, so divide numerator and denominator by what will that be, students? You can just calculate. It will be square root of 1 square, which is 1, and plus root 3 square is 3. So I have square root of 4, that is 2. So what I have to do? I have to divide here by 2. So dividing numerator and denominator by 2. You can calculate this number somewhere, okay, and then write here 2. So dividing numerator and denominator by 2. So I will get I equals to 1 upon 2 dx, and here I have cos x minus root 3 sin x, the whole thing divided by 2. Okay, so the next step, what I will get? So I will have this, the numerator 1 by 2 will come out, and once again I have 1 dx. Okay, see this 1 by 2 I can once again write outside the integral, so I'll have 1 dx, and here I will split this 2. This 2 I will split, so cos x upon 2 and minus root 3 sin x upon 2. So I will get here cos x upon 2 minus root 3 sin x upon 2. Okay, so this is 1 upon 2 outside, 1 upon, see here, this one I write as 1 by 2 cos x. Okay, I can write cos x by 2 can be written as 1 by 2 into cos x, and here I will write root 3 by 2 into sin x and dx. Okay, now see here what I will do. For cos x, see, for cos x, I have the coefficient as 1 by root 2. What is cos x multiplied to here? 1 by 2. I'm sorry, it is 1 by 2. Cos x is multiplied to 1 by 2, and sin x is multiplied to root 3 by 2, and between this I have the sign negative. You know, students, 1 by 2 can be written as cos pi by 3. Yes. Cos pi by 3 is 1 by 2, and here sin pi by 3 is root 3 by 2. See, because we divided by 2, that is because we divided by the square root of coefficient of cos x square plus coefficient of sin x square, the things have turned in our favor. That is, it mathematically it has turned in our favor. Whenever you do this, you will notice that number that you have with cos x and the number you have with sin x, they can be written as cos of some angle and sine of same angle. See how interesting this is. You know, cos pi by 3 is 1 by 2, and this is automatically sine of pi by 3. This is automatically sine of pi by 3. Okay, not only that, suppose if you take this as sine of pi by 6, yeah, because you know 1 by 2 can be taken as sine pi by 6. It's up to you. You can take sine pi by 6. If you want, you can take cos pi by 3 for 1 by 2. You can take sine pi by 6 for 1 by 2. But you know what? If you take 1 by 2 as sine pi by 6, automatically this becomes cos pi by 6, and this will solve your problem. This will solve your problem. But let me tell you students, I always prefer to take the constant which I have with cos, I always prefer to take that as cos. Okay, so with cos x what I have 1 by 2, so I prefer to take that as cos pi by 3. So something which I have multiplied to cos x, I will always take that as cos of some angle. So see, 1 by 2 I am taking cos pi by 3, and this will be sine pi by 3. So here next step I will write 1 upon 2, and 1 upon this I write as cos pi by 3. I will write this as cos pi by 3 into cos x. So let me change the order. Cos x cos pi by 3. No problem, you can change this because cos x into cos pi by 3 is same as cos pi by 3 into cos x. Minus here you will have sin x into root 3 by 2 is sin pi by 3. And you know what this becomes? This becomes I equals to 1 upon 2 and 1 upon, check this out students, check this out. What is it? It is cos A cos B. This is cos A cos B minus sin A sin B. It is cos A cos B minus sin A sin B, which is cos of A plus B, which is cos of A plus B. So now I tell you why did I prefer here cos, because I wanted to end up with cos formula. I wanted to end up with cos formula. So next step what I write next step as cos of A plus B, that is x plus pi by 3 and dx. And see students, you got 1 upon cos. 1 upon cos is sec, so you have I equals to 1 over 2 integral sec x plus pi by 3 and dx. Now what is this? You all know integration of sec x dx. What is integration of sec x dx? It is log of sec x plus tan x plus c. So here it is sec x plus pi by 3. Can I use that same result here? Can I use the same result here? The answer is yes. Why? Because x has been replaced by linear algebraic in x. You can check. It is x plus pi by 3. X plus pi by 3 is what? 1x plus pi by 3. 1 is a and b is pi by 3. So the answer will be I equals to 1 over 2 and log of sec x plus tan x plus c. That is log of sec x plus pi by 3 plus tan of x plus pi by 3, the mod closed plus c. This is the answer. Log of sec x plus pi by 3 plus tan x plus pi by 3 inside the mod. Remember students, these two are inside the mod. Okay, these two, sec x plus pi by 3 plus tan x plus pi by 3 is inside the mod. Okay, I'll do one thing. I will write the answer properly so that there is no confusion here while writing the answer. So let me write the answer in the next, on the next page. I will write the answer properly. So here the answer that you will have final answer as I equals to 1 upon 2 and log of mod of sec x plus pi by 3 plus tan x plus pi by 3 plus c. This is what I am getting. So the answer for this is here. This is the answer for question 2. On same line, you can solve question 1. Question 1 is 1 upon cos x minus sin x. So it is, question is 1 upon I equals to 1 upon cos x minus sin x and dx. So what is the first step? The first step is, what will you do? You will, as I told you, the coefficient of cos x is 1. So 1 square, coefficient of sin x is minus 1. So plus minus 1 square under square root. You will divide by this number. And how much is this number? This number is 1 square is 1, minus 1 square is 1. So it is root 2. So you will divide numerator and denominator by root 2. And then you will begin as we had done in the previous question. So you will get 1 upon root 2, and you will divide the denominator by root 2. So it will get you 1 upon root 2 cos x minus 1 upon root 2 sin x and dx. Then what you will do, this cos x, you will write this 1 upon root 2 with cos x, you will write it as cos pi by 4, and this you will write it as sin pi by 4. So you will get cos x cos pi by 4 minus sin x sin pi by 4. In the denominator, this numerator is a pure constant without any variable, so it will go outside. So you'll get 1 upon cos of x plus pi by 4, which is sec x plus pi by 4, and you will integrate the same way as you integrated sec x plus pi by 3. So the final answer you will get is outside 1 by root 2. So like here you had 1 by 2, here you have 1 by root 2 log of sec x plus pi by 4 plus tan x plus pi by 4 plus c dx. That will be the final answer. Okay. So students, I hope you followed everything, whatever we took today. I did not teach you a new concept today. I only solved the problems based on the earlier type of problems, earlier type of integrals that we had done. We took some good questions, practice them well, solve. Remember, solving problems will help you much. Whichever textbook, reference books you are referring, take similar kind of problems, similar type of problems which you learn from these videos and solve them. That will make you perfect. Thank you.